first U.S. Census was in 1790, and the U.S. Constitution requires there be a decennial census of population. However, population and economic information was of increasing importance to the government, so it's been expanded over the years. This is the current United States Census Bureau website. Historically, a census involves the enumeration and registration of people and property for the primary purpose of taxation. More recently, it's become an enumeration in which to attempt to account everybody or everything. Of course, the intent is 100% count of population and housing. The census population numbers are used to apportion the 435 seats of the House of Representatives, determine state and local political districts, distribute federal funds, state funds and local funds to individual neighborhoods, and then to evaluate state and local programs. With regards to data collection, the Census Bureau conducts a population and housing census every 10 years, an economic census every 5 years, census of governments, which is conducted every 5 years, the American Community Survey, which is done annually, and the Service Bureau also collects data for other entities like the Bureau of Labor, the Department of Housing and Urban Development, and the National Center for Health Statistics, and many others. Here's a diagram of census geography. Census gathering in the United States requires continuous revisions to its geographic delineations and its established hierarchy. Primary nested geography includes the smallest unit of geography, the census block, that comprises block groups, and then within the census tracts, the block groups are nested. And then the census tracts all fit nicely within counties, making it very useful for GIS analysis. While these are the primary units of geography, there are other delineations that are designated for special purposes. So of note here, things that might be used are zip code tabulation areas, which I'll talk about later, urban areas, and then public use microdata areas that can be aggregated later on or up to different levels of geography, which I'll also talk about later. The core-based statistical areas, or CBSAs, are urban areas that have at least 10,000 people tied socioeconomically to an urban center. The acronym CBSA represents areas defined as metropolitan and micropolitan. Micropolitan areas being those with a population above 10,000 people but below 50,000 people, and metropolitan being those areas with a population of over 50,000. When metropolitan statistical areas, or MSAs, are geographically within close proximity and engage socioeconomic spatial interaction, they are considered combined statistical areas, or CSAs. To distinguish a CSA from a MSA is based on the level of interaction. MSAs will have considerable more interaction within the MSA than with other MSAs within the CSA. So as of 2010 census, there were 128 CSAs in the United States. If we look to the southeast region, the Atlanta, Sandy Springs, Gainesville CSA abuts the Athens, Columbus, and Macon MSAs. It has become the central metropolis of the southeastern United States and is the dominant feature in what's called the Piedmont Atlantic megaregion. It includes Charlotte, Nashville, Birmingham, Raleigh, Durham, and other areas of the Carolinas. The Atlanta MSA is the 9th largest in the United States, consisting of 28 counties. The MSA covers 8,376 square miles, contains over 140 towns and cities, and has a human population of 5,268,860, based on the last census, which was in 2010. The Atlanta Regional Commission provides GIS data for this MSA, and then it has a lot of other infrastructure data. It's a key organization involved in defining and planning the Atlanta region The commission is engaged in regional planning for 18 of the counties and serves as an intergovernmental coordination agency for the core 10 counties surrounding the city of Atlanta. The agency works with local governments and the U.S. Census Bureau to update census geographies. With regard to GIS data resources and mapping demographic data, the agency maintains current census boundary geometry files and state data and data tables already referenced in the state plane coordinate system. This is appropriate for mapping use at the regional level for Atlanta. Other useful GIS data include infrastructure like roads and railroads, hydrography, and it also has a series of downloadable land use data. All of this is in shapefile format. And now let's talk about census geography. There's a few key terms to discuss first. The first is aggregation. Data is aggregated when it's summed or averaged up over a particular area. For example, a census block group, or tract, which are referred to as summary levels. Often data is collected at the level of households or individuals, thus the data can be aggregated up to the geographic levels for mapping purposes. Aggregating up is often used to mask the spatial location of the people the data represents. And perhaps there's a requirement in your particular project to protect the confidentiality of persons, or perhaps you want to aggregate all the data to the same geography for analysis. So now looking at census geographies below the state level, the census geography is nested. That is, census blocks fit nicely within block groups, which fit within tracts, and tracts fit entirely within counties. So for GIS applications, this is essential in order to do the majority of vector-based geoprocessing functions. The level below the counties is the census tracts. Tracts range from 1,500 to 8,000 people, but the Bureau targets 4,000, and they're delineated locally whenever possible and is meant to be as fairly a homogeneous and permanent area with similar demographic and economic characteristics and living conditions. So basically, they're approximated neighborhoods. Here, the census tract for Stone Mountain, a large park area within the urban county of DeKalb in the Atlanta MSA. It's just to the east of downtown Atlanta. Note the size differentiation with a factor of land use and population density. The tract also has a corresponding FIPS code, useful for joining data to the geometry file in GIS. So if you had gotten a data table of socioeconomic data, you can then use a common key field and join that to this particular census tract. Now, block groups, they range from 600 to 3,000 people, but the Bureau is targeting about 1,500 persons. And within the Stone Mountain tract, there are 3 block groups. Note the difference in size here. Then we have blocks, and blocks are defined by roads, but may also be bounded by rivers, streams, railroad tracks, or invisible boundaries like city or county limits. In urban areas, they use road center lines and typically have a population about 85 people. Only the short form information is available at this level. Again, note the differences in size. So here are the census boundaries for the Stone Mountain tract and the block designated for the actual mountain. If we look to Stone Mountain's west, we can see the town of Stone Mountain. Note the circular shaped boundary. This was the original planned town city limits. Most towns were delineated by a large range ring drawn on the map from the center of town. Over the years, most towns in Georgia have annexed new areas in their city limits, changing the shape of their boundaries. However, we can still depict the original city limits in the block level boundaries. Also note the rectangular block boundaries. Census boundaries are usually bounded by natural major features, street center lines, and then delineated by population range. The U.S. Bureau coordinates with state and local governments to continually update these boundaries given changes in land use and population densities. Now let's shift to something else. Zip codes are often data that's used in GIS mapping, but there's a big problem in using zip codes with census geography. The aerial units don't match up. Zip codes are a collection of mail delivery routes, not aerial features. Areas exist even that don't have zip codes, and there's buildings that may have its own zip code. Zip code boundaries don't play very well with census boundaries. The U.S. Census releases, however, zip code tabulation areas, ZICTAs, which are generalized representations of zip codes, but available data is incomplete. Statistical data available for ZICTAs include the 2000 and 2010 censuses, the 2007 to 2011 American Community Survey, 5-year estimates and later. But you may not have it definitely for historical situations, but it is an attempt to try to generalize the zip codes to match up with zip code, to match up with census geography. Now let's take a little closer look at census geography, look at how the data lies out on top of each other in Atlanta. So here we have the Atlanta MSA. The counties are delineated by these red boundaries, and then within the different colored units are the zip codes. So in this map, we can identify that zip codes clearly do not match county boundaries. If we add the census tracts, we kind of see the same thing. It's a bit more complicated. So it's going to make geoprocessing between census tract and zip code very difficult. Here's a view of just DeKalb County to zoom in. Further, block groups don't line up and add to the trickiness of trying to work with zip codes. And let's look at a zoomed in view of DeKalb County. And with them all being nested, of course, block groups don't work either. Here it is across the Atlanta MSA, their aerial delineations. And then let's look closer at DeKalb County. That said, city level data doesn't work well either. So the areas in tan are city limits around Atlanta, and the red boundaries or the red boundaries around DeKalb County here in this image. So a key way around this when working with GIS could be aggregation. For example, if you had address data that you wanted to use with census data, you could do what's called geocoding the addresses as points, put them on the map, and then use GIS to capture those points that are within a specific census geography. So geocoding is one strategy to take address data and then aggregate it up to some sort of level of census geography. Key source for census data, of course, is the American Fact Finder. This is its new interface as of 2012. You'll be able to find and build data tables, and then you can use that information to join to geometry files or to use in GIS, or you could just use it directly in a statistical package. Key resource for people doing GIS is the Tigerline shapefiles that are available for most years. The census boundaries can be downloaded from this site. They have new releases each year, and they can be used in conjunction with demographic and economic data that you've downloaded for the American Fact Finder. They have both a web interface, and then you can also use its FTP site to download the shapefiles and use in GIS. Another key resource, if you want to look backward in time, is the National Historical Geographic Information System. It provides both shapefiles and tabular data for all the censuses going back. And you can build up and then do time comparisons in a GIS package. One thing to note too is that they have what's called the Sabins data. It's aggregate data and boundary files for school attendance boundary zones. It's here placed within the National Historical GIS. If you're interested in the historical changes in county boundaries, the Newberry Library releases the Atlas of Historical County Boundaries. This data is also available to download and use in a GIS program. So let's review the key things of census geography that we've just discussed. There is data available beyond the decennial census. Specialized censuses that have been taken can also get historical census information. Census geography is nested, thus it's very useful in GIS processing. Zip codes in census geographies don't play well or don't play nicely together, but there are ways or strategies around it, either the ZICTAs or doing something with address geocoding. And data can be aggregated to mask identifying information or make data work with other data. That's another reason to do aggregation. Some key data links mentioned here are on the right. The American Fact Finder, the Census Tiger files are available here. If you're looking at Atlanta, the GIS data available at the Atlanta Regional Commission, which is quite useful because it's all in the same coordinate system or spatial reference. The National Historical GIS System and the County Historical Atlas.